Okay, we'll begin because I don't know how long this will take. All right, I was hoping that I was going to have a news posting for you by now about the midterm, but I've got some like weird little problem. I've got to wait for somebody to say, yeah, it's okay, because there's some talk about it being a different time than what I said it was going to be. I'm still going to fight to keep it the same time, but unfortunately, it's kind of something out of my hands. Anyways, even though I don't have an exact time, trust me, as soon as I get this, I will post it. The plan is still the 28th of February. Okay, it's supposed to be at 11. I will let you know if that's a confirmed time or if it's a different time or maybe it's a day early. I don't know yet. Okay, sorry, not anything I can control. I'd rather leave it as it was because that's what I said it was going to be. In any case, there will be some MCQ questions, basically tracing, not anywhere near as difficult as what we do in the Kahoots. But you know, some of the exercises we do in the quizzes are not bad. Those are a little easy. And those little mastery quizzes, those are actually not bad either. Okay, some of those are kind of tricky. No, I usually don't put multi-selects on them. And those are usually the very difficult ones. Just to give you an idea. There's always two, and by the MCQs are worth about half. It's all about tracing. Most of the time it's what's the output of this program, because we're checking, okay, do they know what an append does? Do they know what an extend does? Do they understand what happens when you concatenate things together? Do they understand that when you ask for input you get a string? This type of thing. There's always, as the second part, there are always two programming questions. One programming question is worth like 40%, and I call it standard questions. I don't want to describe it as, oh, it's easy. No, I don't want to say that. It's at a level as what I would expect that you should be able to do in this course. And then there's always one challenge question, but it's only worth 10%. And really, that's to kind of make a difference between the people between an A and a B and so on. That's what it's really there for. And generally, that gets graded pretty harshly as well. That's usually all or nothing. Students don't fail because they couldn't do that question. They fail because they couldn't do the first one, okay, which is the absolute standard. In terms of topics, basically everything until last class. So the stuff I'm covering today, the stuff I will cover next week, this is not part of it. Okay, so there will be nothing about tuples and sets on the midterm. The labs, basically all the lab modules from 1 to 6, so that includes next week's. The evaluated labs from 1 to 4, we'll do lab number 4, I think, before the midterm, and quizzes number 1 and 2. We'll have all of those things out of the way. Okay. During the test, yeah, you'll have basically it's two parts. The first part is the MCQs. All the MCQs will be on one page. Yeah, it'll be in lockdown browser. Once you finish that, you go up to the programming. The programming, then you have access to the interpreter. Once you switch to the programming, you can't come back. Okay. All of this is in a note ready for me to post. I just have to wait until somebody says yes, the time is good. Okay. So, but now you at least have all of the other information. If I don't get a confirmation of the time, I will at least paste everything else except for the time as a posting by like tomorrow. Okay, on to the real material. So, yes, this is not part of the upcoming midterm. So why are we doing it? Well, because the midterm isn't coming for 2 more weeks. So we either have the midterm like this weekend, or I do nothing, and I can't do nothing because we have 2 weeks worth of stuff that we have to fill. All right, so yeah, this is why. So it's kind of weird. It goes a little out of sync, but it's the only way I can really do this in terms of keeping on top of the content and finishing everything by the end. Or the alternative is I could include tuples and sets on the midterm, but I'm not going to. Okay, because we don't have a time to run the exercise. Okay, so here we go. Tuples and sets, something completely new. Well, sort of. Okay, and it always bumps into this is what's new, what's different, and what does he mean by sort of. All right, it's one of the sections that wasn't well covered by the textbook, the OpenStax textbook. So yeah, there's an appendix which will explain all of the nitty-gritty details, and I will show one slide, then we'll have to do a bunch of examples of it, and then I will probably be stuck in the interpreter for the rest of the class. All right, so here we go. I even dragged some stuff at the bottom. I'll deal with that on my own, so don't worry, it's going to come back. So tuples are like lists, okay, but immutable. Okay, tuples are ordered. Elements have fixed positions. You can use indexing, square brackets, and loops to iterate through the elements. Tuples are defined using commas and usually include parentheses. Most lists most list operations, other than any type of thing dealing with modification, works on tuples. Okay, put it away because we better see what one of these tuples actually looks like. All right, so here we go. I said they're like a list, so let's start with a list. Okay, so here we go. Yeah, the usual thing. Yes, I like doing this. It's let's have some scores because everybody will understand test scores. So that's why I keep coming back to it. Isn't that it's the only thing? It's just everybody understands it. All right, so there you go. There's a bunch of test scores. Okay, so what can you do with a bunch of test scores? Well, we can do a whole bunch of things. We could input. Well, not input, but with a list of test scores, what can we do? Yeah, you can append, okay, to add something to the end. What else can we do? Okay, you can get rid of things. Okay, so we can put things in, we can remove things. Okay, so somebody's pointing at this one, sorry. Here you go. All right, so yeah, you can modify the number of elements inside. What else can we do? Something very, very important. Yeah, you can change individual elements without changing the size of the collection. And you might say, well, that's pretty obvious, but you know what? If this was a different programming language, for example, if this was being taught in Java, you can do this operation, but you can't change the size of a list. Okay, it's just the language doesn't support it. Python does, so that's nice. So you can modify things. You can do a bunch of other things. For example, things that I didn't have a chance to show you yet, but kind of showed up the other day on the Kahoot. So hey, we will do this. For example, there's an operation called reverse, and that's great if you have a list one way and you want it backwards. Okay, there's a reverse. That doesn't have a lot of use. This one right here, sort, that can be useful because that would put things into increasing order, which allows me to find the smallest element, the biggest element. All right, remember that we have access to being able to find things. We have access to being able to count things. We have the ability to find the biggest and the smallest and the sum. Yeah, okay, yeah, these are things that you might possibly want to do. All right, so there we go. That is a list. Okay, oh, how do we know it's a list? Okay, well, pretty simple. I will prove to you that it is actually a list. I mean, maybe I've been lying the entire time. All right, but here we go. If I print out the type of scores, I have to spell it correctly. It tells me, yeah, it's a list. Yeah, okay, yeah, good. So I haven't been lying. Okay, so now it's time to start lying? No. What I'm going to do is I'm going to introduce a slightly different contraption. Okay, and that is, sorry, get my fingers on the right keys. Here we go. I made a little change. Not much of a change, is it? Okay, yeah, instead of square brackets, it's parentheses or round brackets. All right, is this a list? Well, it certainly looks like a list, because if I asked you a question like, how many things are in that collection? What are you going to tell me? 5, yeah, of course. Could I ask you to find the biggest thing in the collection? Yeah, sure, it's 97, and the smallest thing, no problem. Is there an element at the beginning of the collection, and what's its value? 70, yeah, and what's the very last one? Yeah, 45. And guess what? Elements don't just pop around whenever they want to. They will stay exactly in that same order. What this means is that this is an ordered collection. Okay, this is an ordered collection, and its type happens to be a tuple. Okay, yeah. So that's the difference, is square bracket. Yeah, that's it. All right, now the secret, of course, is that tuples are supposed to be immutable. All right, that was the word, okay, and that's the official word from Python. And what does that mean? What that means is that you can't modify a tuple. Okay, you might be able to throw the tuple out and make a brand new one. That'll be something different, but a modification to a tuple means that I shouldn't be able to do something like this, even though that worked perfectly fine with a list a few seconds ago. And that's exactly it. Tuples do not support item assignment. Okay, so that's one. Okay, somebody else suggested about, everybody tells me that there's an append. Okay, here we go. You have a list of scores. You want to put a 99 at the end. What do you think? Yeah, it has no attribute called append. Yeah, you can't append. But there are other things that you can do. For example, you can print them, Okay, well, that's not very exciting. Oh, but of course, when you print it, it shows up with round brackets rather than square brackets. Okay, could we calculate the sum of all the scores? And the answer is, yeah, actually, we can. Okay, now, okay, I'll leave it to somebody to punch it into a calculator to make sure it's all right, but I think it's probably correct. Okay, there's nothing weird going on. That should be the sum of absolutely everything. And if I ask for the minimum, what are we expecting? 45, and that's exactly what it is. And guess what else at the max? Looks like a 97, and yeah, that works. Good, so finding things and so on, yeah, this works, and so do most of the operations such as count. So remember what the count does. The count will count how many times something occurs. For example, how many 80s are there? Yeah, there's only one, so it shows up this way. And if I was to stick another 80 in here, yeah, now it'll tell me 2. Yeah, so looking for things to count, the index, which will tell you where things are. Okay, so here we go. That was the index. That'll tell you the location of the first 80 it finds. And here, I'll just change it to something different. Here you go. So the first 80 it found is position number 4. Yeah, all of those looking to see what's there, they continue to work exactly the same way. It just happens to be that you don't have an append, you don't have the ability to delete, you can't pop, you can't insert, you can't do any of this stuff. Okay, excellent. So it's like a list, only it's more restrictive. Why do we have them then? Okay, so let's have some reasons to actually create them. All right, so for this exercise, let me pull out a function that I wrote a little while ago. Okay, just so I didn't have to type it over here because I wanted to do a certain thing. All right, so let's take a look at what we've got. And no, this is not an exercise in spot, debug, and tell me what's wrong. Okay, there's actually a whole pile of stuff that's wrong with this, by the way, so this is not the purpose. But here's the idea. Somebody suggested that we should write a function that computes the average test scores, but if there's any scores less than 60, we bring them up to 60, and we calculate the average on that. Okay, so in other words, if somebody fails really bad, we just kind of ignore it, and that way it'll be good if somebody says, "Hey, what's your class average?" and basically your line. Okay, well, fine. That's not our purpose. Anyway, whatever we're doing, maybe we need to do some statistical analysis on the students who have passed, or we say, okay, ignore the people with the really low grades because maybe they dropped the course. Okay, that could be more legit. All right, so take a look at this. This is what the programmer came up with. They said, okay, they have a total. Okay, eventually they're going to take the total divided by the length of the test scores. Okay, that makes sense. And what they're going to do, this is the way it got implemented, they said, okay, let's go through all of the items inside the list using an index-based loop. I'm allowed to do that. Okay, yeah, I know that there's a for-value loop would be a lot better, but we're using an index-based loop. And we basically ask the question right here, if the scores at the given index are less than 60, here's what I'm going to do is I'm going to append a 60 at the end, and I'm going to continue, which means I'm going to ignore the current value. Seems pretty reasonable, right? Yeah, logically, it kind of makes sense. Yeah, skip over the value and just continue, but stick a 60 at the end so that when I get there, it'll be counted. Seems pretty reasonable. Otherwise, okay, just add it up. So if there's no problem, just keep on adding. Yeah, it could have been in if else. All right, so let's do it. Okay, so we have like some midterm scores. So here we go. Midterm scores, okay, suppose the midterm scores came at 60 or 70, 80, 50, and 90. Okay, and we're going to calculate an average. So here we go, compute average, and we're going to pass in the midterm, and I'm going to print the average, put in the right order. Here we go, 48. So what do you think? Is that right? Well, it better not be because, I mean, everything is above 48 to begin with. So having an average of less than 50 is going to be really suspicious. Because remember, what was supposed to happen, we were supposed to get rid of the 50, and it was supposed to be replaced by a 60. Okay, that's what should have happened. But it actually gets even worse than this because watch this. If I print this time, and I simply print it again and again and again and get rid of the average at the end, take a look what happens. Every time I'm running it, I keep getting different things. What's going on? Okay, there's kind of some surprising things going on here. Okay, here's the first thing I'm going to do, just so you get the idea of what's happening. Oh, sorry, I'm going to print the midterm scores just after I call. Okay, does that look like the right thing? No, because there's now a 60 tacked onto the end. That's why when I call it again, that's why I got a different average, because now there's a 60 at the end. Yeah, the 50 wasn't counted, but the length was counted. Oh, it's very, very strange. All right, so we're not going to debug this, but yeah, that piece of code that I wrote right here, this is absolutely terrible. Don't do this. The correct way to do this, calculating the average, getting rid of these things, is I would start with an empty list, and if the score is bigger than 60, I'd append it. If it's less than 60, I'd append to 60, and then calculate the average of your new list and throw it out. All right, here's a problem. Remember that lists are mutable, and as a result, anything, if I do something to scores, I'm actually doing it to midterm. Because it's mutable, remember I created an alias. That's why I talked about aliases the other day. Okay, they're very, very dangerous. You don't want to have these types of things. All right, so how do you fix it? Okay, write your code better. Yeah, of course, right? Of course, that's always the answer. Just write the code better. Unfortunately, it's not always the case that you wrote the code of maybe being somebody else. Okay, and maybe you don't trust them. Okay, so if you don't trust them, you see, when I call this function compute average, it's actually messing up the midterm. All right, here is the first reason why you might have a tuple. Okay, tuples, you can't change anything. There we go. Now they're a tuple. It's the same data, but now it's a tuple. Okay, if it's a tuple, can the function change it? And the answer is no. In fact, if I try running this code right now, it blows up with a runtime error and it says, oh, tuples have no attribute called append. What you're doing is you're sort of making it very obvious that whoever wrote this function is probably messing up with things. That's a very convenient way when you have to call a function and you don't really trust what the other person has done. Okay, and trust me, this happens all the time. People are always using functions that somebody else has done. But I can guarantee that after this, if I got through it, okay, here, let's make this one hide. Turn hiding. Oh, that's not what I want. Okay, that makes it even worse. There we go, now it's gone. All right, so the thing is that, yes, what I've done now is I've guaranteed, you see, all right, let's just get rid of this for a second. I am absolutely guaranteed that what shows up here on this line is still the original. That's what I'm getting. I'm guaranteeing because it was a tuple. Now, of course, what somebody should say is, yeah, but what if I didn't have a tuple in the first place and somebody gave me a list? Because maybe the list came from somewhere else. Maybe we asked the user for it and we kept appending. That's pretty reasonable. Let's do that. Let's absolutely do this. All right, how many scores do we want? Okay, let's do it this way. While true, I'll ask for a score. I'll ask for an S, just so it's different. Okay, ask for a score, int input, enter score. I hope this ends up working, doesn't burn me all this time. If S is equal to -1, then I'm going to break myself out of the loop. Otherwise, I'm going to say that midterm.append S. There we go. All right, scores. That one will work because nobody had a score less than 60. All right, so here we go again. 70, 50, 80, 90, and a -1. Yeah, so you see, we've got the problem, and yeah, somebody has corrupted this entire thing. All right, so if we wanted to turn this into a tuple to prevent the problems, what do we do? Okay, so your first guess is going to be, well, sorry, somebody's first guess. Maybe it's not everybody. What do you think? Maybe change something right here? Yeah, I bet what some people would try is this. If I said turn it into a tuple, they might do this. And trust me, it happens all the time. So don't say, no, I wouldn't do that. Trust me, I've seen it happen enough times. There's actually a whole pile of issues with this. Okay, there's actually many issues with this. We'll find out later. But where's the first place where you know for sure it's going to break? Which line number is going to cause some problems? 19. Because remember, it says right here, midterm.append, and can you append to a tuple? And the answer is no, you can't. All right, so in other words, this isn't going to work. The only way this input's going to work is if it happens to be a list. So how do I get it turned into a tuple? All right, well, it turns out it's actually not bad. Let me print midterm, and let me print a second line. I don't even care about this other thing because this is very, very important. Okay, there's an operation called tuple. And what it does is it takes a whole lot of different things, including lists, and it will turn it into a tuple. Okay, so let me just show you this one. So 56, it doesn't even matter if I've got failing students or not. Here we go. Sorry, -1 to stop. So there we go. You see, the very first print that shows up, yeah, that's definitely a list. You can tell it's a list because of the square brackets. The second version is a tuple. So what you can do is you can turn it into a tuple when you call the function. Now you're guaranteed that nobody's going to mess with things. There's the first reason why you might want to have a tuple. It's used for this type of thing. All right, so here's the next piece, what we're going to use it for. We're going to have to do some analysis on a test. Okay, so again, I'll just use the test scores because everybody understands it. So test analysis. Okay, we're going to pass in a bunch of test scores, and I'm going to return, sorry, 2 things? No, you can't do that. Okay, the function's going to calculate 2 things. Actually, you know what? I'm going to calculate 3 things because they're all very simple. No, 2 things will be good enough. Okay, the smallest. How do you get the smallest? And by the way, scores is a list or a tuple. Yeah, min. Okay, minimum scores. All right, and the largest. Max, okay. And yeah, you could do other things as well. I'll leave that for another exercise. Oh, and maybe I spelled the word largest correctly. All right, here we go. If I print the smallest and I print the largest just to see what's going on, and I will return the value 0 for right now. I promise to come back to it. All right, and let's have some test scores. So here we go once again, midterm. So some scores. I don't even care what the values are. Okay, here we go. And what I'm going to do is I'm going to call test analysis, and I'm going to pass in the midterm. All right, so my question is when I run this, nobody's getting that score. All right, when I run this, what should we see? 12 as the smallest, yeah, followed by 90. Okay, good. Let's check it. Yeah, 12 and 90. That's exactly it. There's nothing funny going on yet. All right. Well, we've been through the course now a little bit, and I hope that last week's exercise was enough to kind of make people realize, like, oh, right. In a function, yes, you can print things, but it's not very useful because we don't have any idea what somebody's going to do with this. Maybe I'm supposed to find the largest and the smallest. I'm supposed to calculate the average between the smallest and the largest. Some kind of a statistical measure. All right, and I can't do that if the function prints it. I can do it if it returns the smallest and the largest. But the problem is how many things can you return? You can only return 1. Well, let's try some stuff. All right, so here we go. This is going to be what I'm just going to call the result, and I'm going to print result, and I'm going to ask the question, what's the value of result when I run this? Yeah, it'll be 0 because that's what I'm returning. All right, let's see if we can return the smallest, and we can also, return the largest. Yeah, only the smallest will be returned because as soon as you hit a return, that's it. The function is now finished. It doesn't go any further. You never make it to line number 6. Okay, excellent. You remember that one. All right, well, okay. Yeah, is that going to give me both things? And the answer is, of course not. It's going to calculate the sum of those two. All you know is that it comes to 102, so you don't know if 2 was the smallest and 100 was the largest. Yeah, that's obviously not going to work. All right, so we start to come up with other crazy ideas. So here's a crazy idea, which is not a very good idea. Okay, somebody's already yelled it out, and we'll explain this in a second. All right, here we go. What if I did something like this? And I'm not suggesting that this is the right way to do it, but I have seen lots of programs do this. All right, do I get back both numbers? Yes, I do. Okay, excellent. So, but here's the problem. Can I add those 2 numbers together out here? No, because it's a string. Yeah, so that's no good. All right, somebody was just yelling at me a second ago, well, you put a comma. And the answer is, yeah, actually you do put a comma. And it returns two things. That thing that I just printed, that is result. What is it? What type? It's a tuple. There you go. So this is the second reason why you might want to have a tuple, is if you have a function that needs to return more than one thing. Okay, that's one approach. Oh, and by the way, I don't think this is in the slides anywhere, but I'm going to do it now anyway because it can be sometimes surprising. All right, here's the way whenever I'm dealing with tuples, it turns out that the parentheses are not actually necessary, but I always like to include them so it's absolutely clear what I've got. Okay, so it's one of those things. You don't absolutely need to do it to make a tuple, but you'll usually find when I'm writing tuples, I will write it this way so that it is very clear what we've got. All right. Oh. What if I did this? Yeah, it's a list. And what's going to be in the list? 12 and 90, it just happens to return this way. It's another way that you could return multiple things. Most people in Python, if you want to return multiple things, you use a tuple. Okay, so generally you would. You could use a list. You have to be careful because sometimes you get a function where somebody does something weird, but most of the time people would probably use a tuple. That's one of the reasons why we end up using it. Okay, so there we go. That's the usual thing. Oh, and now if you want to do something with it, okay, let me see what's coming up next. Oh, perfect. It's exactly what I want. All right. Let's go forward because now I want to calculate the average of the smallest and the largest. Okay. And to calculate the average and the smallest, you'd add the 90 and the 12 and divide by 2. Okay, let's suppose we wanted to do this. So let's call it AVG. All right, how do I get the smallest? Well, I've got this thing called result, which is a tuple. You can see it right there. How do I get the first value? If it was a list, how would you get the first value?
First index.
Yeah, first index. So you use square bracket and 0. Good. That would be the first thing. And it also works with a tuple because, yes, it works exactly the same. All right, and what would you add this to? Result at 1. Okay, good. You take the sum of these two things and you divide it by 2 and you print the average. And there you go. There's a 51. All right, so yeah, this is how you do it. Now, here's the issue. Result 0 plus result 1. It's not very clear what it is it? I mean, it's valid. It certainly is valid. But sometimes maybe there's things we could do to make life a little bit nicer to look at, easier to understand. I mean, this is what we're always looking for. All right, so this one is really cool. You see, the first thing that comes out was the lowest. Yeah, I know it's a different name. Okay, it was the smallest. Lowest and the other one would be the highest. And what do you think? Oh, and I'm not going to do this, sorry. Oh, sorry. I'm going to take this piece of code right here. I'm going to put it here. I'm going to remove this one. There we go. Sorry, that's what I was really looking for. All right, so now when you call test analysis, it comes back as a tuple. We know it comes back as a tuple. On the left-hand side, the thing right here, what type is that I just highlighted? Tuple, guess what? They are exactly the same thing. The tuple consists of two variables, lowest and highest. And the way how this works is exactly what you might think it does. Yeah, it actually separates them. So now instead of having square brackets and so on, now my average could be something like lowest plus highest divided by 2 and then print an AVG. And here you go. There's the 51 again. It's a little bit more convenient. Okay, I mean, that's really all that it is. If you have a tuple, yeah, you can return it this way. Okay, what do you think? Think that works? And the answer is yeah. Okay, it works the same way. I know we're supposed to be talking about tuples, but yeah, it's kind of related because it does say tuple unpacking here, but actually you can also unpack lists. You can actually unpack anything else as well. That's very convenient, and we need to cover this stuff as well because sometimes students get themselves into trouble because they think they have a list, they got a tuple, and so on. It's good if you know what is actually possible. All right, and this is really just a convenience. Oh, and of course, something very important. Sorry, let me go back to my result for a second, because I did say something. For x in result, print x, and I'll just print the result. So what am I doing here? It looks like I'm attempting to iterate over, and that's exactly what I'm doing. It works exactly the same. So in other words, it's just like a list, except that you can't modify it. All right, next example about why you might use tuples. Okay, for this, I have to make things a little bit more complicated. So if at the end of this you go, I don't really understand what happened, completely fine. Okay, this is not part of the course. This is just another reason why you might want to use tuples. Some library packages actually use tuples. In fact, a lot of them use tuples. So I got one small example over here. Okay, so as I say, you won't necessarily understand all of this, but actually some of it you should be able to understand. Okay, so what this is, the very first thing is I'm bringing in some package. Yeah, it's not a package we should cover in the course, don't worry. The first thing I do is I try to connect. Well, I hope you guys understand what all this stuff is. Those are just named arguments. All right, because it turns out that you actually don't need to provide things like the host, you don't need to provide the port because those are actually default values already. All right, so all I'm doing is I'm saying please connect to a database. What's in a database? Data. Now, I'm going to ask the user to enter a username. I've got a couple of names if I remember what they are. Okay, I might have to look it up. I hope I actually remember what these things are. And take a look at this. I'm interested in this statement right here because take a look what I just highlighted. What does that look like? Yeah, it's a tuple. I can see the parentheses, I see the comma. It looks like something's missing, but I can see the parentheses, I can see the commas, and yes, that is actually a tuple. All right, so here we go. I'm going to go ahead and I'm just going to run this again. This is not part of anything. Now, I got to remember who is in here. It wasn't Alice. Sorry, give me a second. I've got a list of people in here. Where's my art gallery? Because if I don't ask for something that I can find, then we won't see anybody. All right, this was an exercise a couple of years ago for, art gallery. Okay, I think artists. There we go, select. Okay, who have I got? I got somebody called Diana. Yeah, I would never remember that one. Okay, here we go. When you ask for Diana, what's going to happen is it's going to look up in the database and it's going to return something and print it. And of course, what I'm really kind of interested in is what type of thing did it return? There you go. You see, they show up all over the place. Okay, so as I say, even if you don't understand this, I don't care. It was just to say that, yes, there's a lot of stuff where tuples show up all the time, and that happens to be one of them. All right, so you notice that there was one weird kind of looking thing. Okay, so let's do this. Let's have some just generic data. Okay, I'm going to make it a tuple. And it's going to look something like test scores. I don't really care. Print data, and importantly, print the type of data. All right, this is not a trick question. When I print it, how many items are in the tuple? 3, and it will better tell me the type is a tuple. Oh, and by the way, slicing works the same way. Okay, yeah, lists and tuples are exactly the same, except you can't modify them. All right, so I would like to get rid of the number 25. And I'm going to run the program again. Okay, any difference this time? Yeah, it'll only show 2 items. What type is it? A tuple. Okay, very good. So there you go, 45 and 34, and that is a tuple. Okay, let's get rid of this one right here. All right, how many items are there this time? 1, and what type is it? No, it's an integer. It's just a number 45. Okay, but there's parentheses. Yeah, well, remember, you can use parentheses in expressions. All right, here's kind of the weird thing. If you want to have a tuple with exactly 1 element and no more than 1 element, you have to kind of hint it and say, yeah, there's a comma, and all you're doing is you're saying Yeah, please treat this as a tuple. Okay, it's not actually the parentheses that make it a tuple, it's the presence of a comma. So even something like this, here, I'll clear the output so we got a fresh one. There you go, that's still a tuple. Okay, excellent. All right, so well, you've seen what I've been doing. I've been removing things. So here, let me put the parentheses back for a second. All right, I went with 3 elements, then 2 elements, of course, and 1 element. And now, of course, what I need is that seems pretty reasonable. So how many things are in my tuple? Looks 2, really? Yeah, it looks like nothing. Okay, and what type is it? Oh, it looks like a tuple. Okay, so let's find out. No, that's an invalid syntax. Okay, tuple with 1 element, kind of a special case. A tuple with 0 elements is also kind of a weird case. Here's the way how you make it. Okay, yeah, I know it looks incredibly weird. All right, there's what a tuple looks like with no elements. Okay, let's get back over to my slides. Where do my slides go? Because I want to make sure that I'm not forgetting things. All right, tuple example, tuple concatenation. Okay, ooh, all right, here, let's do this. Okay, data. Okay, list for a second. All right, 4 underscore in range 5 print enter, sorry. Value in, make it an int, input, enter value. Okay, and I'm going to say data.append value, and I'm going to print the data. Okay, the underscore is a placeholder. I'm not using the variable name. Okay, that's sometimes what I will do. You can use index, you can use I, it's fine. All right, so it's going to ask for how many values? 5. And then it's going to print them. Okay, excellent. What if we wanted to do the same thing with the tuple? Can we do it? Okay, first of all, that's not how I say an empty tuple. What do I do? I have to use the tuple constructor is officially what it's called. You might refer to it as a tuple function. I would be okay with that. All right, so here you go. You have a tuple function. All right, where's the problem going to appear? On the append, because it'll ask for the first value, but then it blows up and says, yeah, you can't do that. And you say, all right, we can't do it. All right, got 2 solutions to this one. All right, first one. There you go. Bring it in as a list, convert it over to a tuple. Yeah, okay, that's one way. I got another sneaky, weird-looking way, because, of course, you know I'm going to have one of these. That's an empty tuple. I can't append a value, but here's something that I can do. I can concatenate tuples. Take one tuple and another tuple and jam them together, just like we did with strings. All right, the only thing is I would need to have a tuple with the value in it. And let me trash this one. And of course, because it's a tuple with 1 value, I need those weird the commas. I always like the parentheses around. This will also do it. Okay. It turns out it's not very efficient, but you could do this. Most normal people would bring this in as a list and then convert it to a tuple at the end. It's a better approach, but it's here. It's in the slide, so I've done it. Okay. Anything else about tuples? Okay. I've already said, why do we use tuples? Okay, excellent. So we're done with tuples. Okay. They kind of look like lists, don't they? Yeah. There's really not that much else. The only thing that's kind of weird is a tuple with 1 element and an empty tuple look kind of different, but turning them from a list into a tuple and a tuple into a list, by the way, is completely trivial. Okay, just because we're here, sorry, one more thing about a list, and we'll move over to the next data structure. Okay, there we go. Print type of data and data. Data is equal to tuple data. Okay, and then data is equal to list data. There we go. So 3 print statements. The first time that I call a print, what type is it? List. Second time, it's a tuple. Third time, back to a list, and it's always exactly the same values. Yes, they are easily translatable back and forth. Okay, hey, pretty simple. All right, let's put that away. We used to actually spend 90 minutes on this. probably a little too long. I've actually spent more time than I really wanted to on this one, but that's all right. I don't mind. All right, so here we go. On to something new and completely different. All right, well, we did this already, so let's do the same thing again. So here we go. Some data is equal to, square brackets, a bunch of data, and I'm going to print the type of data, and I'm going to print data. All right, this is not a trick question. What type is it when I print it? It's a list. Okay, excellent. And we already know that if I replace this with round parentheses and I run it, what type is it? It's a tuple. Okay, excellent. All right, some new brackets. Really everything. And yeah, this is something new for today. This is something called a set. Okay. So there we go. There's a class called a set. All right. Do you notice something that looked a little bit weird this time, however? Let's see if you happen to notice this. Because there's actually several weird things going on here, which is the reason why I picked these numbers, because I know that would tend to be a little bit different. Yeah, okay, first up is the order does not match what I had before. This falls into something called an unordered collection, okay? It's an unordered collection. It means that the order now is completely different. Yeah, the 1022 still ended up at the end, but take a look at this. You see the 6993, it ended up at the beginning when I printed it. There's no guarantee of order. And here's the way how things work. Okay, what could happen and what will happen. If I print exactly the same thing again, there's absolutely no guarantee that it will be the same order. There's no guarantee of it. It's going to be, but there's no guarantee of it. What we mean when we say unordered is that there's no guarantee of an order. In other words, I can't ask you which number comes first because, I mean, somebody may have said, well, it was 5465, that came first, but of course when you print it, it comes out as 6993. Yeah, so you can't actually make a prediction about where things are. That's the first thing. Second thing, which I know somebody has already said, yes, something weird did happen. Notice the number 1332. It was in the line number 1. It showed up twice. But when I printed it, it disappeared. Second thing about sets, they get rid of any duplicates. In fact, that's probably the number one reason why you might use a set for anything is to be able to get rid of duplicates. It's really good at this type of thing. So if you ever end up with two items with the same value and you don't want to have two items of the same value, all you do is you turn it into a set and all of the duplicates are gotten rid of. All right, so what types of things can we do with one of these things called a set? All right, well, so let's start asking. First thing, obviously I can print it. Okay, next thing I'm going to ask, what do you think? Data at position 0, I mean, what would that print? What do you think? Makes a really good MCQ question. Does it print 6993? Does it print 5465? Is it some kind of an error, or is it the number 1022? Okay, got one vote for an error. Anybody want to try the others? And I suppose I could have brought up a Sakut and said, okay, here you go. Nobody dares. Yeah. Okay, that's fine. Yeah, we'll save the daring request for the Kahoots. It is an error because sets have no order. Okay, you can't ask for the first element because there is no such thing as the first element. There's no such thing as the last element. However, what you can do is you can use a few things. For example, for X in data, they do allow you to iterate through, oh, sorry, but you have to not hit weird buttons. They do allow you to iterate through them, which is very useful because sometimes you just want to look at all the values to see if something is there, okay? Or maybe to remove certain numbers, like maybe you want to get rid of even numbers and so on. So yes, you can do stuff like this, okay? So you can iterate. So there is kind of a concept a little bit, but the way it actually works is it takes the set, turns it into a list, and iterates over the list. That's the way how it operates internally. Okay, you don't have to worry about it here, but that's actually what it does. All right, so, but every time that I iterate, will it be the same order? Yes, but there's no guarantee of it. Okay, and that's always the difficult thing is, yes, it will probably always look this way, but if you were to take this same program and try it on your computer, I don't mean inside the this PyLock editor, because it'll be the same there, but if you try it, say, in idle, or if I open up PyCharm and try the same thing, it might not show up in the same order. It depends on the implementation of Python. Okay, all right, so it's really, really good for dealing with getting rid of duplicates. Here's the slide. The best use for a set is getting rid of the duplicates. Excellent. However, it has some other operations, because if you think back, where did you see sets before? You saw them in your math course. All right, and I'm sure when you covered stuff in math, they almost immediately threw you into a bunch of operations called unions, intersections, and differences, and maybe even symmetric differences. Okay, and yeah, if you're thinking, oh, this is coming back to math, yeah, it is coming back. Because sometimes these math operations are very, very convenient. Okay, so I think I've got a couple of examples over here. Not this one. Oh, sorry, I have to do some stuff first before we get there. Oh, okay, that's a nice question. Let's find that out. Okay, all right, so first of all, okay, we'll print everything. First question up was, can we find, say, the smallest value in a set? And the answer is yes. Again, the way how it works is internally it turns into a list. Or maybe it iterates through everything. Okay, it doesn't matter. But yes, the min works, which means that the max also works, which means that the sum also works, as long as they're all compatible types. You stick a string in here, and you got yourself a trouble. Okay, so for example, if I type this, that's going to blow up because now they're incompatible types. Okay, nice question. Thank you for asking that one. Okay, we better find out, okay, can we add remove things? Because remember, we always had these append operations. Okay, data.append 100 at the end, print data. What do you think? This is kind of an English question as well. What do you think? You think it's going to work? What does the word append mean? Add something where? At the end. Is there an end to a set? No. That's why it doesn't work. Okay, that's why they didn't support the operation called append. If you would like to put something into a set, the operation is called add. Okay, and it works exactly as you expect. If I, well, what if I try to add something else? Like if I try to add 1022, it basically completely ignores you. This isn't whatever, it's already there. Okay, all right, so that's this one. Good. So that's for putting things in. Let's try this one. What do you think? Okay, why not? Because normally this gets rid of the thing at the end, and there's no concept of something called the end. Yeah, so, yeah, sometimes there's a lot of weird things that happen. Okay, yeah, so wait a minute, what on earth happened to this? Yeah, they've done some really strange things. To be honest, I don't think they should have actually provided this operation. Well, what the heck is it doing? Because I didn't even put it here on my operations. Generally, you would do the first of all, what did it pop? I mean, the first element. All right, so well, in that case, let's try this. If it popped the first element, okay, so here is what I believe that it's doing. I believe it starts to iterate through, and the first value it finds, it removes it. Okay, I didn't include it in here because, I mean, how useful is that? Because remember, the set's not ordered anyway. Okay, let's move on to the things that are really here. Okay, so the add is no problem. Okay, the pop is kind of weird, and actually I don't always necessarily agree with some of the stuff the Python designers have done. Generally, however, what you might do, and there is an operation for this. All right, but here we go. Here's one operation, remove. Okay, so what does remove do? Well, just take a guess. And don't worry, you won't get this one wrong. It removed the item that you're interested in. Okay, just like what it does inside a list. Okay, so at least that's sensible. What if I asked to remove the value 45? And that blows up just like what it does in a list. Also with a key error. Okay, so no, it's not there. However, there's another function which is pretty close. It's called discard. And what it does is it removes the element, but if it's not there, it kind of ignores you. So if you just want something to go away and you don't want to check and see if it's there first, you can use discard. All right, and then of course, we've got the pop operation, which kind of does something weird. Basically what it's doing is it's randomly picking an element and discarding it. Useful? Maybe not. I've never used it in the course before, so I don't think you have to go off and deal with those. The discard and the remove and the add, these are things that happen all the time. Here's another one that's very important. If I ask a question whether or not 45 is in the data, is it? No, false. And if I ask if the number 6993 is in the data, that's true. Okay, so that operation works exactly as we expect. All right, now, here's where things start to get a little bit more interesting. Okay, here's what I'm going to do. I've got some code over here so that I don't have to type it. It'll take way too long to type. And I accidentally pressed the wrong button. Okay, excellent. Let me press enter here, and here, and here, and here. All right, what these are a list of students. Why do they make them as strings? Just because. Okay, they could have been integers. That would have been fine. Just strings. Okay, and what I've got is I've got a bunch of student IDs who are taking a course called Comp 1001 and a bunch of students who are taking a course called Comp 1002. Okay, very quickly, tell me who's in common, who's taking both of these courses. It doesn't look like very much fun, right? I mean, could you solve it? Yeah. Do you want to solve it? No. In fact, it's just like, no, I'm not going to do that. Okay. Can a computer solve this? And the answer is, yeah, you can. All right. And here's the way how you deal with this. You have to think back to your set operations from your math course. So remember, now, do I have a picture of this? I can't remember what my slides have a picture. Yeah, not union, not for this one. Yeah, it's the intersection. Those will give you the things that are in common between each other. So what we're talking about, let me see if I can very quickly draw a small Venn diagram for you. Okay, just to remind you how this is. So here we go. Insert one circular shape. Okay, here. And copy paste. And we'll put it over here. And, sorry, just let me remove the shape fill. There you go, no fill. All right, so remember the Venn diagrams. So what I'm talking about the stuff that's here in common, okay, called the intersection. Okay, let's drop this out of the way. So is it possible to compute the intersection? And that is, yes, it is. All right, so common students. All right, so all that we need to do is take the Comp 1001 and figure out how to calculate the union. So in math, it looks like this. So I'll write that for a second. And Comp 1002. That's what it should look like. But of course, guess what? It's not a U. Okay. Now, what they've done is they've picked a bunch of things that are, it almost makes sense. There's the first one that they picked, the ampersand. Now, if you see the ampersand outside of this course, you see it in a sign somewhere, what does it usually mean? And, yeah. So Comp 1001 and Comp 1002. That's the intersection. Okay. This actually is not bad. So print common students. There you go. There's the students that are in common. Okay, that one's not bad. All right. Somebody suggested a few minutes ago about the union. Okay, so here we go. The union, of course, is talking about everybody. But what do we do with the duplicates? Well, remove the duplicates because you don't want to see the same name listed twice. You just want to have everybody who is, of course, unique. Oh, and remember, that's exactly what sets are used for. So I'll just call it all students. So everybody, Comp 1001, and okay, again, if it was math, you'd put something that looks like an N, and you say Comp 1002, and print all students. But of course, guess what? It isn't the number N. The good news is it's actually not difficult. No, it's this way. Okay, yeah, it's this way. You add the two together. At least I hope. These things I always forget how we. Oh, no, it doesn't, does it? Let's add it together anyway and see what happens. There, clear the output and let it run. So what do you think? No, you can't add them. Okay, all right. Somebody just said it a few seconds ago. They said the word or. Okay, yeah. Oh, and by the way, other programming languages, this means and. If I showed you JavaScript, that's what we use for ands, even inside if statements. And since I see a couple of people nodding, saying, yeah, okay, what do you use in those other languages for ors? The line, okay. It's right here. It's a vertical bar. Okay, it's a vertical bar. You'll find it right around the backslash. Usually it's close to, yeah, it's usually close to the enter key with a shift. Okay, so it's somewhere around there. That is the combination of both of these things, with, of course, the duplicates removed. What if you want all the items plus the duplicates? You can't do it with a set because you can't have duplicates. These are set operations. All right, so here we go. Next one. All right, let's see, what would we want to do? All right, another. How about this one? The students that are taking Comp 1001 but who are not taking 1002. So what we're talking about is this guy right here. I'm talking about this part, okay? This part right here. That's called the difference, okay? Now, in your math course, you would have calculated the difference by saying Comp 1001. You know what, let me get rid of these. Let me comment these other ones out just so it's here. The way how you represent this in your math course, you would have said Comp 1001 subtract Comp 1002. Okay, and Comp 1001, not Comp 1002. Wow, that's a big, long variable name. Okay, I should have made it easier. All right, the good news is that's exactly how you use it here. So yes, that is one. So these are the students who you will find in Comp 1001, but anybody who's taking Comp 1002, they will be removed. Okay, so it's a set difference. Okay, so that's the next one. Okay, what else have we got in here? All right, and finally we have one extra item that I also have to include, and because I have no idea what it's called yet, let's just do it as X. Okay, X is equal to Comp 1001, Comp 1002, print X. All right, somebody who may have just walked in, it would be too bad somebody didn't just walk in right now because we could ask them, what does that mean? What are they going to tell me? If they don't know? They're going to tell me exponents, because this is what it looks like in Excel. And sometimes this is how we write things. If you wanted to calculate 4 to the power of 7, people would write stuff like this. It's not correct. It doesn't work here in Python, but this is actually a valid operation. A little difficult to explain, and I'll probably have to make a very simple example. Okay, so we're going to simplify absolutely everything. Okay, so I'm going to make it as simple as possible. A and B, B and C. Okay, I think this should make it pretty clear what it's doing. It shows A and C only, but it doesn't show the B. It's called a symmetric difference. It's the things that are not in common. Okay, so we're talking about the union minus the piece in the middle. So in other words, we're talking about the people here, we're talking about the people here, and we're not talking about the people in the middle. Okay, all right, so there we go. Yeah, so if you have a math problem you're trying to solve, it works really well. What types of math problems? We don't solve math problems. It's very, very handy for solving problems like this. I want to find out which things are in this group that are not in this group. Trust me, I use this all the time. I used to use this when before they started putting the card taps that actually interface directly with PeopleSoft. What I used to do was I used to get the students to tap anyway. I had access to the list of students. It showed up as a list, and I threw them into a set. Okay, I used to take everybody in the class, throw them into a set, and then what I did was no matter how many times somebody tapped, I would remove them from my set, and then I would be left with just the people who didn't tap, and then you'd go through and you'd remove the checkbox on each of those items in PeopleSoft. I automated the entire thing. Yeah, we do use sets for this occasionally. It is more than just kind of a math thing. If you want to get rid of duplicates, it's really good for that. If you want to be able to do operations to clean things up, it works really well. You know, I've already covered most of this stuff, converting between list sets and tuples. Yes, this actually does exactly what you think it's going to do. Here we go. If I said data is equal to a list of comp 1001, and I print data and I print the type of data, take a big wild guess about the type of data. Yeah, it's going to be a list. And what values are going to be there? A and B. If you take a list and you turn it into a set, it's going to have all the same values unless there are duplicates, and duplicates are going to go. We've already seen this. Okay, so here we go. That was exactly my useful for doing the following. Wow, I still got a lot of extra things. All right, you know, I've actually done quite a few of these things already. Converting types. Okay, so okay. I won't run it, this one. If I find something that's really interesting, I will do this. But otherwise, I'll talk through it so I don't burn up too much time, because I see I'm past 3 already. I know I'm running on borrowed time. All right, so the items start off as 0. I go through 6 times, and I'm appending. And then, of course, what happens is I do this conversion right here to say, take the items, turn it into a set. But then what did I do? I turned it back into a list. And then I stored it as items. What am I doing? Well, you see, when I turn it into this right here, set at items, all the duplicates go away. And then I turn it back into a list. So that can be quite useful. Turn it in this way. There's something really cool where sets are incredibly, incredibly fast. Okay, I would like to do this one, and okay, the day, no funny Kahoot thing. Save it for next week. All right, so because this one is actually pretty cool as well. Okay, I've got a program that I'm going to show you. You don't have to understand the program except for a couple small parts. Okay, so don't worry about if you look at the program and you go, whoa, this is very complicated. It's actually incredibly, incredibly interesting if I'm very careful about what I show you. Okay, so don't be freaked out by the program, but I'm going to show you a bunch of functions. Okay, here's the first function. Okay, not a big surprise. What does the function do? Even though I didn't put a doc string, which I should have, what does the function do? Oh, come on. What does the function do? It creates a list. Okay, good. How big is the list? N. Any number. Okay, and you're absolutely right. I go through and I append a bunch of numbers to it, n times. And what am I appending? Random numbers. They're just random numbers, okay? It's just a huge list of random numbers, okay? Done. All right, I got another one. This function right here, what does it do? Creates a set. Very good. What is how many elements? N. And what are the values it goes in? Random. Yeah, it's creating a random list of sets and a random set and a random list. Okay. All right. I got another function. That one's pretty tough. What does it do? Finds the value. It tells me whether or not the value X appears in the data. Okay, that's it. And how does it work? It just uses in. Okay, that seems pretty simple. All right, now let's look at the real program. Okay, so that's all it's doing, just setting up a list. All right, so here's what we do. All right, data create a list. It says create 10,000 items in this list. What 10,000 values? Random. I don't even care what it is. All right, next thing up. Okay, this is a little bit funny. I start a timer and I end a timer. Okay, well, what are we talking about? Here you go. I'll give you an idea about how this works. It's called a stopwatch. See, how does a stopwatch work? Well, what you do is you start a timer, you do something, and then you stop a timer and you figure out how much time went by. That's all that this is doing. Okay, so when I asked for start and stop time, that's all I'm doing is measuring how many seconds. All right, what am I doing? I am going in and I am going to repeat an operation 100,000 times, and what I'm trying to do is I'm just trying to do searching for random values. I just look for a random value, look for a random value, look for a random value. That's it. Okay. I just want to know how much time this takes. Okay, so for a list, all right, remember, it's a pretty fast computer. I mean, I know it's a couple of years old now. What do we think? We need an estimate about how long this is going to take when I run it. So here's the scenario. There's 10,000 values in a list. I'm going to search 100,000 times. Is that going to be like this fast? No, of course not. So I need an estimate for time. What do you think? 5 seconds. 5 seconds. Okay, that's a reasonable thing. Higher, lower, what do you think? 4. Okay, so we seem to be sort of gravitating 5 seconds. Okay, it could be reasonable. Let's find out. Okay, let's find out. Okay, so here we go. It's thinking. I am printing every 10,000 just so that I know the program isn't stuck. Okay? Because if it's showing nothing, it's like, is it working? Is it stuck? Is it an infinite loop? It's not an infinite loop. It's just to let me know that it's getting there. Okay, 15.5 seconds. Okay, that's how long it took. If I tried running this on another computer, by the way, the machine that's here, it's probably going to be slower because it's an older machine. Maybe it takes 20, 30 seconds. It doesn't really matter. If you have like an M4 chip, it'll probably be half the time. All right, so in any case, that's how long it takes to find a bunch of numbers inside a list over and over again. Okay, this is now what I want to do. Instead of creating a list of 10,000 numbers, I'm going to create a set of 10,000 numbers. Okay, I'm doing exactly the same thing. I'm going to put in a bunch of random values, and I'm going to ask over and over again, is this random value here? Is this random value here? Is this random value here? Okay, all right, so what we're looking for is the time. So when it was a list, it took 15.5 seconds. Any idea about how long it might take if it's a set? 7 seconds, okay. Yeah, half the time. That seems pretty reasonable. No, it's a little shorter than that. It's really fast, isn't it? It's brutally fast. In fact, it took more time to print than it did to find. In fact, my whole thing here, the reason why it's that slow is probably because of the print statement right here. If I were to comment out the print statement, I bet it'll go even faster. Okay, a little bit faster. Okay, yeah, so what does that tell you about the difference between a list and a set? Sets are really fast. They're incredibly fast. That's another reason why sometimes we use sets, is if you have a lot of data and you have to look it up really, really quickly, it's really, really good for this. Unfortunately, you can't have duplicates. But is it a big deal? All right, well, imagine this. I have, say, 10,000 students, and I need to very quickly find data for the 10,000 students. Is it better to put it into a list or a set? A set. Yeah, but what about the duplicates? Yeah, well, everybody has a different student ID, so it works really well. That's exactly the type of thing that we use sets for. We don't get to see much of it in this course. So what we deal with in the course is really just the mechanics. We use it all the time for getting rid of duplicates. If you ever get a question that says get rid of the duplicates, it immediately says, okay, put it into a set, put it back into a list, and you're done. That's the way how you get rid of duplicates. Just into a set, back out of a set, and you've got everything done. I mean, that's been like lab exam questions a few times. Of course, now it isn't just that. It becomes a little bit more complex because it's usually inside like a dictionary or something else that you have to extract. But yeah, this is a really cool thing. It's just not something we get to look at. But I like to show it because it's really quite fascinating that, yeah, it contains roughly the same data, but it's so much faster because of the way it gets implemented inside. Okay, but as far as the course is concerned, being able to do set operations to find out which things are in common, which things are different, show me the things that are here that are not in this, it works really, really well. Okay, all right, so 3:10, yeah, there's no time for a Kahoot today, so we will do it next time. I'm sure there's going to be lots of time where we have some short classes. Okay, so see you next week.